Hi, I hope y'all are all staying really warm at home, enjoying these snow days. I am doing lesson 6.6 for you on this video. So take a look. Perform similarity transformations. We've talked about transformations several times now, so you should feel pretty comfortable with them. A dilation is the kind that we do with similarity. We've already talked about that. A dilation, remember, just makes it larger or smaller. Like when you go to the eye doctor, if they dilate your eyes, it changes the size of your pupil. So that's why it's similarity and not congruence. Earlier in the year, we talked about congruence transformations, these up here. Those are keeping the same size and shape. And similarity, we're going to be changing it. When you do a similarity transformation, it's a dilation, but sometimes they combine these others. So it might get larger or smaller, or like this one here, this example, to go from the blue to the red, it got larger and it also moved to the right. So it'd be a translation and a dilation. The scale factor we've talked about is how it changes when you compare the sides and how they change. It's very important that your scale factor be the right number because it's going to tell you if it got larger or smaller. This part highlighted in green, it says if the K is going to be the scale factor. That's what they're using to represent scale factor. If it's between 0 and 1, it's a reduction. It's basically less than 1, like if you take half. If it's more than 1, then it's an enlargement. So really important over here. Make sure you have this written down somewhere. If it's a reduction, the scale factor is less than 1. If it's an enlargement, it's going to be greater than 1. The part highlighted here in pink is the coordinate notation. When we did transformations a little earlier in the year, we used this notation, and it's basically how it changes. That little arrow in the middle, remember, stands for change. This time we're multiplying times k times x, and k times y, because k is the scale factor. That's how we're changing each of the coordinates. First example, we've got these coordinates for a quadrilateral. I wrote them here in blue, and we're going to use a scale factor of 2. So if you look up here in the pink, it says we're going to multiply each coordinate by 2. We're going to get new coordinates. Each of these changes. So I listed out my original ones just to save a little time. And now our scale factor is 2, so we're going to multiply each item by 2. So point A becomes 4, 2. B becomes 8, 2. 4 times 2, 8. This time negative 2. And 1 times 2, and negative 1 times 2. So there's our new coordinates that we're ready to graph. It wants us to draw the dilation. A lot of times it asks you to do both. I'm just going to draw the dilation because of how the problem is worded. So I need to graph these red coordinates that I just got. So 4, 2, 8, 2, 8, negative 2, and 2, negative 2. Straight lines are not my specialty. There you go. Okay, so that's the dilation. And if the scale factor is 2, did it get larger or smaller? Well, if you remember, scale factor that is more than 1 means that it is an enlargement. So this blue figure, if you graphed it from the blue coordinates, it would be smaller than what we just did. All right, another example, I saved time again by listing out the coordinates. It says that a triangle has these vertices. The image, remember this is the pre-image. I might have forgotten that. We haven't used those words in a little bit. This is the pre-image Oh boy, there's an A in there. Okay, and then the image is how it changes, what it becomes. The image after the dilation of a scale factor of 1/2 is DEF. All right, if our scale factor is 1/2, what's going to happen? It's going to go smaller. It's going to be a reduction because it's less than 1. So let's get our new coordinates for D, E, and F. It told us what to name it in the problem. So we're going to multiply each of these times this scale factor. So half of 4 is 2, half of -4, -2, and so forth. We got half it, half of 8 again, half of -4, -2. I graphed the original, the pre-image in blue. Now we're going to graph the image in red. So 2, -2, 4, 1, and 4, -2. There you go. And it did get smaller. If for some reason you graphed it and it was larger, you made a mistake. All right, I put these on here. I'm not going to necessarily do all the steps, but I just want to remind you the process to follow when you have questions like these. First step, list out your pre-image. So make your list. P is -2, -1. Q, -1, 0. R, 0, -1. Then use your scale factor to change them. Get your new coordinates. This one is telling you what to name your new coordinates. So you're going to have L, M, N, and you're going to change them using this scale factor. That's what K stands for. You're going to graph both and make sure that it got larger or smaller depending on the scale factor. For guided practice number 1 right here, the scale factor is 4, so it's going to be an enlargement. In number 2, the scale factor is 0.4. That's less than 1, so it's going to be a reduction. Okay? All right, here's a picture I took of me and some buddies, and I decided I think it'd be really cool to have stickers, because who doesn't want stickers of you and your buddies' pictures? I don't know, most people. So you're going to make your own stickers. Your photo is 4 inches by 4 inches. So the one you have here, this is the bigger one, is 4 inches by 4 inches. It's a square. I cut off the bottom, but there you go. And the image on the stickers is 1.1 inch by 1.1. So when you made your stickers, you made them 1.1 by 1.1. What's the scale factor of the reduction? Keyword. If we're reducing, it's getting smaller, so we need a number smaller than 1. So the two numbers I have are 4 and 1.1. Those are the sides that correspond. Because it's a reduction, you put that 1.1 on top. Sorry, that kind of ran together. And you put 4 on the bottom. You want to make sure you don't leave a decimal in a fraction. So the quickest way to do that, to get rid of it, is multiply both the top and the bottom by 10. So 11 over 40 would be your scale factor. The reason it's not 4 on top is because it's a reduction, smaller than 1. All right, this is kind of like that perspective drawing that you had in the other video. It's just saying that when you have a center, usually the center is at 0 at the origin. And if you drew a line from one vertex to the corresponding vertex, like in this picture, B and Y are corresponding vertices, from the origin, a line would go straight through. Just a neat fact. All right, this last example here. It has quadrilateral that's already drawn, the blue one, and you want to draw something similar, and they've drawn part of it. G, F, and E are graphed, and they want to finish out that shape with point H. If I had that's not the right one. That'd be helpful. Okay, they want to put point H somewhere to finish out that quadrilateral. Well, we know it's got to be somewhere up here because our shape we want is going to look something like that. Okay, so that it will be similar to the other shape, PQRS, that's there. So let's look at our options. 12, -15. That doesn't even make sense. We don't want a negative because that would bring us down here, okay? So get rid of that option. 7, 8. Let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Maybe, but that looks pretty short compared to the other. So probably not. 12, 15. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Maybe 15, 18. These two seem like either one might work, but how do you know for sure? Well, you see how you've changed them so far. R goes with G. Those are corresponding. Point R is 0, 2. And somehow it changed to G, which is 2, 3, 4, 5, 6. 0, 6. What happened? Nothing happened to the X. The Y increased by 4. But remember, dilations, you're multiplying by the scale factor. So you had to multiply by 3 to get that. But I don't know what happened to the X. Let's see. Let's choose Q and F. Those two correspond. Q is 1, 1. And it changed to F, which is 1, 2, 3, 3. So we still multiplied by 3 with those Y's. And hey, look, the X's got multiplied by 3 as well. So if I want to know, let me get another color. I got too much purple going on here. If I want to know how S is going to change so that it can become point H over here, I need to use that same pattern that I'm multiplying by 3. 3 is my scale factor because that's what worked in my other sets of coordinates. So point S is 3, 4, 1, 2, 3, 4, 5. 4, 5. I hope I counted that right. Probably not, of course. Yeah, it's 4, 5. And we want to change it to get point H. Remember, we figured out our scale factor is 3. So 4 times 3 is 12. 5 times 3 is 15. So point H has to be 12, 15. All right, Math Lab will happen tomorrow at 9:30. If you have questions, here's one takeaway. Make sure you're listening well. 2 goldfish in a tank. One turns to the other and says, see you Friday for the punchline. Hope you have a warm, safe little break.